Okay, in this example we need to verify that this function given over here, y equal to 3 times e to the power negative 5x, is the solution of this differential equation. So we are going to show that. Okay, so we are going to verify that. So to verify any function is the solution of the differential equation, what we just need to do is we just need to substitute this back over here on the equation. So if you want to substitute this over here on this equation, what do we need to do? You need to substitute y, right? And which is already, we can do it from here. Whatever is the function given, we can substitute instead of y, and here is y prime. So we need to substitute also y prime by something. How do we get that? Here is y given, right? So y equal to 3 times e to the power minus 5x, and if that is the case, we can get y prime from there by just finding the derivative with respect to x, right? So let's do that then. So let's see here. So we have given y equal to 3 times e to the power negative 5x, right? So just find y prime from there. So to find that, we just need to find the derivative of 3 times e to the power minus 5x with respect to x. And how do you do that? How do you find the derivative of this? So here is a constant 3 multiplied by e to the power minus 5x. So we write down the constant as it is, multiply by derivative of e to the power minus 5x, and the derivative of that can be figured out by using chain rule, right? So we just need to know what is the derivative of e to the power x. I hope you know that. So derivative, I'm so sorry. Let me see, the thickness is somewhere over here, should be fine. So the derivative of e to the power x is e to the power x, right? But if you have a function that is composed with the exponential function, something like e to the power g of x, then its derivative is, by the chain rule, it's e to the power g of x as it is, but also don't forget to multiply by derivative of g of x with respect to x, which is g prime of x. So we are just going to use that formula to find the derivative of e to the power negative 5x. Okay, so here is e, and then composed with negative 5x is something like our this function over here. So applying this formula, we'll be able to get e to the power negative 5x as it is, right? So like this one, but don't forget to also multiply by the derivative of negative 5x with respect to x, which is negative 5. So altogether we have 3 times negative 5 would be negative 15 times e to the power negative 5x is the y prime. So we have already all the required thing here. So we have y, right, which can be, this y can be substituted back here on this term of the equation, and this is our y prime. This can be substituted back here, and then see if this will satisfy that equation. Okay, so let's do that. So I'm going to substitute y prime over here. Okay, so when I do that, this will be negative 15 e to the power negative 5x, right? So instead of y prime, okay, and then plus I have, right, and then I have 5y, so I will have 5 times y, and then y is over here, right? So I'll just substitute that. So I'll have 3 times e to the power negative 5x. Okay, so when I do that, it says that this has to be equal to 0, otherwise this will not satisfy the equation. So let's see if this is the case. So we have this obtained when we substitute, but the first term is just negative 15 e to the power negative 5x as it is. You can look into the second term. When you multiply 5 by 3, then we get 15 e to the power minus 5x. This has to be equal to 0, and that's exactly the case, right? Because this is negative 15 e to the power minus 5x, this is 15 e to the power minus 5x, and when you combine, you definitely get 0. So we have 0 equal to 0. So it's verified, right? So verified. What is verified? This function given over here, right? So this one is actually the solution of this given differential equation.